Welcome to Spring LIB.
Okay, we have a long acid chloride and an amine, an enamine, which is, I'm going to draw it vertically so it's a little easier to see the enamine. At least for me it is. Like so. And we're going to perform this reaction firstly in chloroform, and then we're going to have an aqueous HCl workup, or H3O plus as I'm going to put it. Same idea. And then the question is, what is the product of the following reaction, or the major organic product? Remember that enamines are great nucleophiles when it comes to creating carbon-carbon bonds, and they do this because the lone pair on nitrogen can swing down, forcing this double bond to open, and that acid chlorides make excellent electrophiles in which the double bond on oxygen can swing up. And if we show this in concerted fashion, one of the lone pairs can swing down and kick chlorine off. Right? So we'll generate a new carbon-carbon bond between this carbon and this carbon. We'll lose chlorine, and then we'll reform our carbonyl. Right, so here is our new carbon-carbon bond, shown in red. But that during this, we also generate an aminium, right, because the lone pair on nitrogen swing down, so now it has 4 bonds. And so it is positively charged. We've generated a new carbon-carbon bond and formed an aminium. And then our final step with the aqueous HCl, or as I called it, H3O plus, will simply be hydrolysis of the aminium to a carboxyl group, right? Aminiums with aqueous acid will always convert to carboxyls. And so the way I would think about that diagrammatically is that if we have some aminium which I will color code in blue, this portion, and then I will color code the lower portion in green. If we react this with H3O plus, and I'll draw the oxygen in red, what we will end up with is an amine floating around. And a carboxyl, in which we take the green portion of our aminium and give it a double bond to the oxygen from our aqueous acid, which I'm drawing here in red. Which means that if we color code this blue and color code this green, that it becomes fairly clear what our product is going to look like. We're going to lose this upper portion of the molecule, including the nitrogen, and that will gain a hydrogen, and that this double bond will go from being to a nitrogen to an oxygen instead, meaning our final product will look like this, and that our side product, which it tells us not to include, do not include the amine from which the enamine was derived. But if you're curious, so that wouldn't be in your final answer, but if you're curious, it would basically just be that. Right, but your major product would be that.